Okay, so we're to find the Norton equivalent circuit for this particular network. So the first thing we need to do is that we need to find Rn and then we'll now find In. So to find Rn of all sources. So in this case, of a current source, you open circuit it, which means this is basically be like an open gap, nothing should be here. And then you short circuit this. So this just comes a wire. And then you open the circuit the where the load resistor is. So if I'm to redraw it to look like this. So this is basically what it should just be looking like. To confuse you less, I can just erase this. Okay. So now this and this are in parallel, they're not in series. These are in parallel because they share two nodes, see? One and two. So now you're going to simply say Rn is equals to this and this in parallel, which is equals to 1580 ohms. Next, we need to find In. So to find In, I decided to use superimposition theory since I saw two different types of sources. I saw current source and I saw voltage source. So superimposition theorem. So to do that, first you off the 8 milliamps source. When you off it, that's you open circuit it. The circuit you're going to have is so, and you also have to short circuit this portion. Now for me personally, since this is not going to exist, like just pretend like this part doesn't exist. For me, current flows from negative to positive. So it's going to go like this. And then it's going to come down here. So I write IN flowing down the circuit. The direction matters. So this circuit is simply going to be, in this case, we can simply say that IN is simply going to be 16 over 220. You see, this short circuit will affect whatever is in parallel with it. A short circuit means that voltage at this point is equal to zero. And for every circuit, if two circuits are in parallel, they have the same voltage. Therefore, if this one has voltage zero, this one has a voltage of zero. And if there's no voltage, there's nothing to push current there. This element becomes useless, which means now it's only this part of the current, this part of the circuit, sorry, that we care about. So IN is simply going to be equal to V over R, which is 16 volts over 220 kilo ohms. So that's going to be 7.27 milliamps. Now I'm going to turn off the 16 volts, and in this case we're going to short circuit the 16 volts. This is going to be allowed to run. We're going to short circuit this. Now your direction matters. For me personally, obviously I see this current come like this. I need to split here and here. When it's coming at this point, this is going to be moving. So therefore I know IN is going to be going in the opposite direction. But remember our IN in the last one was going in the downward direction. So keep that in mind. Direction matters. So this circuit is simply going to be, now again this short circuit is going to affect this element that is directly parallel to it. If it wasn't directly parallel to it, then it won't affect it, but because zero here, if you also because zero here. So basically it's just between this guy and this guy. So in order to find, this is bar, in order to find I to apostrophe N, it's going to be equals to 8 milliamps, because that's just the current in the circuit. The IN to apostrophe is going to be equal to 8 milliamps. Generally in circuit, current loves, like when you just put only a wire there, current loves the place of least resistance. You see this place has a resistor, so it has a level of resistance, but this is just a wire. Current will, if the entire current would like to just come here. And that's how you have, oh, my project has short circuited. So that's the thing about current. All the current will flow here. Nothing will actually want to go here again. Nobody likes a hard life, to be fair. So IN Baba is simply going to be equal to 8 milliamps. Now the total Norton current is simply going to be 8 milliamps, the one you got here, minus, because remember they're in opposing directions, 7.27 milliamps, which is going to give you 0.73 milliamps. Equivalent circuit to be 0.73 milliamps then it will be in parallel with the load resistor. So they are equivalent, then it will be in parallel with the load resistor here. So this is your equivalent circuit. Thank you for listening.